this part and this part are constant. This is also constant. Now we are considering the what? The wet. Okay, and this is at the centroid. Right. So now we know that the limits. Okay, so let's consider the limits. So the limits is from 0. And now we know that this is y and this is z. Okay. So y and the upper limit is what? Now the upper limit is, so the centroid is 3.3548. Right. So we know the distance from here to here is 3.3548. And we know this thickness is 1 inch. Right? That thickness is in the 1 inch. So the limits is now 2.3548 to 48. Okay. So we know that this value, okay, in fact, I do apologize. Consider the web. Okay. This has to be a head. Right. So plus. So we know that the width is constant, right? The width is equal to what? 1.5. Okay, so the width is constant. The Z is now 2.3548. 2.3548. Oi. Minus Y. Okay. Oh no, that's Y. And 2.3548 plus by Y multiplied by half. Right? We learned this before. Y is it 1 minus 1 plus and divided by half. So we know that this is a width, this is the depth, and this term over here is a Y bar. So this is equal to 39.677 plus by 1.5 times 0.5 times 2.3548 squared. So it's equal to 4.159. Let me do it again. Yep. Okay. And then it will, so minus by 1.5 times by 0.5, 0.75 y squared, right? Okay, so this will be equal to 39.677 plus 4.159 is equal to 43.836 minus by 0.75 y squared. So we have to check. Okay, check if equation 1 is correct. Okay, so how to check? So the criteria is when y is equal to 2.3548. Okay, so when y is equal, and when y is at this point, so when y is equal to 2.3548, okay, qz must be equal to exactly the same as here. Qz must be equal to what? Must be equal to, what is the qz? Qz must be equal to 39.667. Okay, so when we substitute this in, so qz when it's at 2.3548, so it's equal to 43.836 minus by 0.75 multiplied by 2.3548 squared. it has to be equal to 2.3548 squared times by 0.75. So 43.836 minus by this is equal to 39.677 is correct, right? It's exactly the same. So your check that this equation is correct. Okay. And then finally, we have to we can substitute that shear stress, okay, of as a function of Z will be equal to the shear force, which is 700 multiplied by 43.836 minus by 0.75 y squared, and then divide by the second moment of area, 337.43, and the thickness, as you can see now, the thickness is 1.5. So this will be equal to 43.837 times by 700 divided by 337.43 divided by 1.5 is equal to 60.625. Okay, 700 times 43.836 divided by 337.43 divided by 1.5, and 700 times by 0.75 divided by 337.43 divided by 1.5 is equal to 1.03737 y squared. So now you realize that the function changes already, like what you have expected, right? So if we were to now sketch, okay, so we are going to stop at the geometric centroid. Okay, so what we have is we have a value over here. Oh, sorry, I should not have done that. So if this is our shear, right? So this is our 10, 20, 30. No, not 10, 20, 30. Yeah, 10, 20, 30, 40, 50, 60, 70. Okay. So this is 10, 20, 30, 40, 50, 60, 70. And we know that the maximum is 60.625. Okay. And then when we substitute y, we're going to substitute y is equal to what? 2.3548. Okay. So the shear stress of y 2.3548. So it's equal to 60.625 minus 1.037 times by 2.3548 squared is equal to 54.87. Okay, let me do it again. 1.037 times by 1.037 times by 2.3548. 60.625 minus 90. Wait. 2.3548 squared times by 1.037. 60.625 minus, so it's equal to 54. So 54. Okay, so the shear stress, so 54 is around here. So this is 54.875. So this is how the shear stress look like, and then it will go down to 0. And this is how the shear stress distribution look like. Now you can also, I'm not going to do it, you can also just consider the bottom part. Let's do it, okay? Let's do it. Let's consider. So I'm going to, hopefully I can occupy this small area to do that. Okay, so let's consider the bottom. The answer will be the same. So the width, right? The width is equal to, so the bottom part, the Q as a function of Z, the width is 1.5. And then the depth is equal to what? The depth is equal to, so the entire length is what? Entire 10 plus 1, 11. Okay, so 11 minus by the centroid, which is equal to 3.3548. Okay, so 7.6452 minus y, or minus z, no, minus y. It's a function of y. And then the same thing, 7.65, 6452 plus by y multiplied by half. Why 7.6542? Because this entire length, 10 plus, so this is 11 minus by, so y, so 11 minus by 3.3548. Okay, so 11 minus 3.3548 is equal to 7.6452. Okay, 6452. 6452. So this will be equal. So Q as a function of y will be equal to 7.6452 squared times by 1.5 times 1.5 is equal to, C is the same, 43.836 or 837. Okay. Minus by 1.5 times 0.5, 0.75 pi squared. Okay. So either you guys know this by now. Either we take from the top or we take from the bottom. The answer will be the what? Will be the same. Okay, so the answer will be the same from here. So let me highlight in green or in yellow. This and this are the same. Okay. Okay. I know your brains are hurting, so is mine. I want to do one last problem, and this problem, again, it's not difficult. It's just enforcing the rule. Okay. Before we go for our term test. Okay. So this is our example number. I can't remember now. Example number 4. Now for this case, this you have to really comply to the rules. Okay. So what do I mean by comply to the rules? You have to really like, oh sorry, you have to obey the major rule that the web or the member has to distribute the entire member. Okay, the shear force, sorry, the shear stress and the shear flow have to distribute the entire member. Let me highlight to you why. Okay, because we are going to break one of the rules down here. This is the only question that you have to break one of the rules. Okay, so what is this rule that we are going to break? Okay, so given to us, the spacing S is equal to 0.25 meter, and V is equal to 35 times 10 to the power 3. Okay, so we have to determine the shear force. Okay, develop on each bolt. Okay, we have to determine. Okay, so now we are, so if we look at